Hey everyone, and welcome. All right, so today what we're going to be doing, we're going to be looking at Pythagoras' theorem a little bit more. I know we kind of already built it up in that last lesson where we were doing an investigation using paper, squares, and triangles. But today we're going to look at actually applying Pythagoras' theorem and using it to solve different sides of right-angled triangles. And then finally, we'll wrap up with logging into Khan Academy. It's going to take us a few minutes to log into Khan Academy, which is why I have it allocated in the class, and then we will do 2 assignments on there. Central questions: what does Pythagoras' theorem tell us about right-angled triangles? And then how can I use the formula to solve for a missing side of a right-angled triangle? Let's go. So Pythagoras' theorem, first thing we need to know, it's a squared plus b squared equals c squared. So we have a squared plus b squared equals c squared. When we think about it, the a and the b values are interchangeable. It doesn't have to be shortest is a and middle is b. It can be the other way around, so it could look like this. They're interchangeable. The c value, however, or the one that is on its own and is the sum of the other two, must be the hypotenuse. And the hypotenuse is always going to be opposite the right angle. So that's something worth noting, that the longest side of the triangle will always be opposite the right angle of the triangle. So, and that's true actually of triangles in general, that the longest side will be opposite the biggest angle, and the smallest side will be opposite the smallest angle, and the middle will be opposite the middle. So just bear that in mind. Bigger sides are opposite bigger angles, smaller sides opposite smaller angles, and so on. So if we think about this triangle here as being a 5, 12, 13 triangle. So that is, the sides are 5, bottom is 12, and hypotenuse is 13. If we make a square on each of the sides, so we say, okay, I'm going to take that side length and I'm going to square it, which means I'm going to now have the area of a square with that side length. If I take the two smaller squares and add them together, I will get the larger square. And that is what Pythagoras' theorem is, that the sum of the square of the two smaller sides is equal to the square on the hypotenuse. There's another visual of it. If one side is 3, the other side is 4, the hypotenuse is 5. You add their squares up together, so we get 9 plus 16 is 25, and 25 is the same as 5 squared. So if we've got this particular scenario, so a squared plus b squared equals c squared. If I want to get c on its own, I would have to square root both sides, because square rooting is the opposite of squaring. It's the opposite function, the inverse function. So it's what undoes it. It's what will undo it. So c is equal to the square root of whatever the other two sides squared and added together are. So using that information, find the missing side of the triangle. So in the orange one, we are missing the hypotenuse, the c value. In the green one, we're missing one of the other sides, so it can be the a or the b value. So in the first one, you've got 3 squared plus 7 squared is equal to c squared. So that'll be 9 plus 49 is c squared. So that would be 58 is equal to c squared. And then you're going to have to square root both sides to get c on its own. So the square root of 58 is equal to c. Now at the moment, that square root one is in what we call radical form. So when it's in square root form, it's called radical form. Sometimes we'll leave it that way. Other times we'll put it in decimal format. So if you were to do the square root of 58, you would get 7.61577, or we'll do 7.62 if we round. Typically round to 2 or 3 decimal places in geometry. The higher the level of math, the more places you typically round to, because we want more accuracy. So we're up to about hundreds or thousands at the moment. For the green triangle, we would have 6 squared plus b squared is equal to 10 squared. So 6 squared is 36, 10 squared is 100. So b squared would be equal to 100 minus 36. So we would subtract it from both sides. B squared is equal to 64. Square root both sides. B is equal to 8. So that missing side is 8. Pretty straightforward. Okay, so these are just going to be practice triangles for you. I'm going to pause on each one for just a couple of seconds, but I want you to pause the video, try and solve for x, and then unpause it, or just play it again so that to see what the actual answer is. So pause the video now, try and solve for x, and then come back. Okay, so this one, the hypotenuse is missing the longest side, so it's going to be 9 squared plus 12 squared is equal to x squared. So that'll be 81 plus 144 is x squared, and that's 225 is equal to x squared. So 15 is equal to x when you square root both sides. All right, in this one, we've got a hypotenuse of 29, base of 21, and x. Solve for x. Pause the video and then come back. All right, so hypotenuse we've got, so it's going to be x squared plus 21 squared is equal to 29 squared. And then you're going to have to subtract the 21 squared from both sides. So it's going to be x squared is equal to 29 squared minus 21 squared. So we put that in our calculator and see what we get. 29 squared is 841. 21 squared is 441. And then x squared is there. So we've got 841 minus 441 is 400. So we'll have to do the square root of 400, which is 20. Another one, 7, 13, and C. Pause the video, come back, see what the answer is. All right, so we've got the hypotenuse missing again, so it's going to be 7 squared plus 13 squared is equal to c squared. 49 plus 169 is equal to c squared. 49 plus 169 is 218, which is not a square number, so we're going to square root both sides. And we get 14.764, so 14.765 is equal to C. All right, this one was a little bit of a challenge one that we did in class. I'm going to give you the hypotenuse is root 200. I'm going to give you x on one side, and I've put these hash marks in which tell us that this is a, I feel like I'm doing Blue's Clues at the moment, or Dora, but this is a isosceles triangle. So using that information, solve for x. Pause the video, come back when you want to see the answer. Okay, so because it's isosceles, that means that this side is also x. And Pythagoras Theorem still does its thing. So root 200 squared. Root 200 and the square part are just going to cancel. So I'm going to be left with 200. And x squared plus x squared, going back to your Algebra 1 days, is 2x squared. Divide both sides by 2. And I get x squared is equal to 100. X is equal to 10. Did you get that? If you didn't, make sure you always come into class and say, hey, Mr. Phelan, I didn't quite get that. Can you explain it once more? All right, different type of question. Could 4, 8, and root 80 be the sides of a right triangle? Now, this is actually working what we call a converse of a theorem. So a Pythagoras theorem is if you have a right triangle. So if given a right triangle, the sides will fit the formula a squared plus b squared equals c squared. Now that's kind of like a slightly different version of what Pythagoras' theorem is, but we'll go with it right now. So then what we are saying, and sorry, there should be if then, so then should be in here. So an if and then statement. So if some criteria exists, then something else exists. The converse is if you switch those. So if the sides of a triangle fit a squared plus b squared equals c squared, then the triangle must be right angle. And that is what we call a converse statement. So you're reversing the if and then statement for a rule, a law, a theorem, whatever it is. And if it's true, then the statement goes both ways. For Pythagoras, this is true. So if you can show me that the sides of the triangle fit a squared, b squared, and c squared, so a squared plus b squared equals c squared, then the triangle must be a right angled triangle. So it's not just any old triangle, it must be a right angled triangle if it satisfies Pythagoras' theorem. So we would check and see, does 4 squared plus 8 squared equal square root of 80 squared? So 16 plus 64 is 80. So that is a true statement. 80 is equal to 80. So we would say yes. For this one, 5, 10, and 13. So you've got 5 squared plus 10 squared equals 13 squared. 25 plus 100 equals 169. 125 equals 169 is not a true statement, therefore this is a no. Now in this one, watch out, 73 is not at the end of the line. These are slightly jumbled up numbers. You want to go smallest to largest, so like A, B, C. So is 48 squared plus 55 squared equal to 73 squared? So let's see, 48 squared is 2304. 55 squared is 3025. And 73 squared is 5329. And you add those together, you get 5329. So they do match, which means this is a yes. All right, so we're going to switch over to Khan Academy now. If you weren't in class, please go into our material section of our class. It'll either be on the home page or it will be at the folder at the bottom, which is just additional material for this class, and click the join link. So that'll connect you to so you'll see Mr. Phelan's math class, so it'll be assigned as your teacher, and then I will have 2 assignments waiting for you to get started. So don't just go to Khan Academy, please go through the Schoology link so that it logs you in, and log in using Google, so it'll pull in all of your school information so you don't have to put anything else in. All right, that brings us to the end for today. Pythagoras' theorem tells about right angled triangle that the sum of the squares on the 2 smaller sides is equal to the square on the larger side. And you can use the formula to solve for missing side by either substituting in for the a and b values and then solving for c, or subbing in for one of the smaller sides and the c value and solving for the missing one by subtracting and then taking square roots. Don't forget to do Khan Academy. I'll see you next time.